Hello, pre-algebra students. Mr. Lawrence here with your flipped lesson, and we're going to do something the next couple days. It's actually kind of cool and a lot of fun, and has the ability to help you feel very, very good about math. Now, we're going to start with something really basic you've been doing for probably a couple of years. It's really just too darn simple for you, and that is, they give you a list of numbers, and then they say find the next three numbers in the sequence. Well, 5 to 10, 10 to 15, 15 to 20, 20 to 25. Hey, they're counting by fives, and so then 30 comes next, and then 35, and then 40. Now, that's an important skill to be able to determine that, but it is also very, very basic, a very low level. We're going to do something a little more difficult. And perhaps difficult is the wrong word. Let's say advanced. And we're going to be able to find any term in the sequence. If you look at it, you found the 6th, 7th, and 8th terms. Well, I'm going to show you a way to find the 100th term without listing 95 more blanks and then filling them in. We'll be able to find the 1055th term if we want. And we're going to do that by finding a formula called the nth term. And all the nth term means is a formula for some unknown number. We'll be able to use it to check the first term and make sure our first term matches the original first term. We'll be able to find the millionth number if we want to or if we're asked to. So let's take a look at how to do this. It's actually pretty simple. Hopefully you noticed my new design of my smartboard equipment. It's pretty cool. Just downloaded it yesterday. All right, here I have the numbers 5, 10, 15, 20, and 25. First thing I'm going to do is I'm going to make a table. And real simple, you just take your pencil and separate the numbers by vertical line segments. And I'm actually going to make 3 extra compartments, and you'll see why in 1 second. And then go like that. Now, the 5 is the first term, so I'm going to put a 1. The 10 is the second term, third term, fourth term, fifth term. And I'm looking for the nth term. I'm also going to look for the 70th and the 302nd terms of this sequence. Okay? Now, just trust me, this is really pretty easy stuff. The first thing I'm going to do is I'm going to find what's called the first difference. First difference. I'm going to see, how do I turn 5 into 10? Well, I add 5. 10 to 15, I add 5. 15 to 20, I add 5. That's, of course, counting by 5, so everything is 5 apart from each other. When I have a repeating first difference, I take the number that's repeating and I multiply it by n. Now, this may be my answer. Well, then again, my answer might just be very close to it. So I make a series of blanks underneath the 5, the 10, 15, 20, etc. And what I'm going to do is I'm going to take these numbers here, this 1, the first term, and I'm going to put it in for n. So in other words, this first one is going to be 5 times 1, which of course is 5. Okay, the next one will be 5 times 2. And that, of course, is 10. Following that pattern 5 times, do 5 times on all of them. And this one will be 5 times 3, 5 times 4, and then 5 times 5, giving me 15 here, 20 here, and 25 here. Now I'm going to compare. I'm going to compare the ones on these little dashes to the original ones. 5 and 5, they match perfectly, don't they? 10 and 10, they match perfectly. 15 and 15, 20 and 20, 25 and 25. If they match perfectly, then I know that my nth term is 5n. Now most of them won't match perfectly, but that's okay. I'll show you what to do in that case. All right, so to figure out the 70th term, I'm going to take 5, I'm going to multiply it by 70, which is going to equal 350. So the 70th term, if I were to make 65 more blanks after the 25 and fill them in all the way, I would get to 350 on the 70th blank. All right, I can also do that with the 302nd term, excuse me. And I know that 302 times 5 is going to be a 0, carry the 1, it's going to be 0, there's the 1, and 15 is going to be the number 1,510, 302nd term. I don't know about you, but there is no way I want to make all those blanks 297 and figure them out, or try counting on my fingers all the way up that high. Okay, let's see how another one goes. I'm going to move this sequence up a little bit here. Oop, lost part of my number. And just for the purpose of the table, I'm going to get rid of the dot, dot, dot at the end. The dot, dot, dot is the way I signify that this thing is going on forever. So I turn my numbers into a table. And then and I put my first term, second term, third term, fourth term, fifth term, nth term, and this time let's find the 83rd term and the 617th terms. Just to reemphasize the point that I can find any number in the sequence if I know the nth difference. All right, nth term, excuse me. So we're going to find our first differences. Looks like it's going up by 3 every time. Plus 3, plus 3, plus 3, right? That means my answer is going to be something like 3n. It might be 3n on the nose, might not. And again, you'll see what happens when it's not on the nose. All right, so now I'm going to take these numbers here, the 1, 2, 3, 4, 5, and plug them in for n. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. And I'm going to compare. I'm going to see how the red ones compare to the black ones. Are they exactly the same, or do I have to add something or subtract something? And in this case, it looks like they're all exactly the same, meaning that my nth term will be just plain 3n. So now I'm going to do the 83rd term. I'm going to do 3 times 83, and that's going to be 249. My 617th term, I'm going to do 3 times 3. So I'm going to do 1, carry the 2, that's going to be a 5. 3 times 6 is 18, 1,851. All right. What this really means is if you are counting on your fingers by threes, when you had raised your 617th finger, the number you would say would be 1,851. I don't know about you, but this way seems a heck of a lot easier. All right, let's do this one here. And again, I'll get rid of this dot, dot, dot because it's in my way for the table. It's important to the problem. All right. So I'm going to make my table. Now this one's not going to match perfectly. I did 2 easy examples just to show you how it works. All right. So we're going to go 1, 2, 3, 4, 5, and then we're going to go n. And let's look for the 100th term and say the 777th terms. All right, again, first thing I do is I find my first difference. And it looks like I'm adding 4 every time. Okay. Well, my answer is going to be something like 4 times n. Okay. So now I take these numbers here, the 1, 2, 3, 4, 5, and I plug them in for n. So 4 times 1 is 4, 4 times 2 is 8, times 3 is 12, 16, and 20. And now I do my comparison. You'll notice they don't match. So I ask myself, how do I turn 4 into 5 plus 1? How do I turn 8 into 9? I add 1. 12 to 13, I add 1. 16 to 17, I add 1. 20 to 21, I add 1. That means to the 4n term, I have to do 4n plus 1. Yeah, right there, that green one is part of my answer. See? 4n plus 1. Now to do the 100th term, I'm going to do 4 times 100. Then I'm going to add 1. Following the order of operations, I'll get 400 plus 1, which is 401. To do the 777th term, I'm going to have to show my work over here a little bit. 4 times 7 is 28, and I'm going to carry the 2, so that's going to get me a 30. And I'll carry the 3, and that's going to get me a 31. And then I have to remember to add 1. So my answer is going to be 3,109. Because remember, I added 1. And there you go. This should be looking pretty simple by now. All right, let's try this one. Again, I want to get rid of my dot, dot, dot. Make my table. All right, first term, second term, third term, fourth term, fifth term, nth term. Oh, I don't know. This time let's find the 91st term and the 500th term. I go looking for my differences. I've got the first difference of plus 6. Second difference is plus 6. Third difference is plus 6. Fourth difference is plus 6. My answer is going to be 6n. I take those numbers 1, 2, 3, 4, 5, etc., and I plug them in for n. 6 times 1, 6 times 2, 6 times 3, 6 times 4, and 6 times 5. And I compare, how do I turn the red ones into the black ones? Subtract 3. Subtract 3. It looks like on every single one, I'm subtracting 3. That means my answer is going to be the 6n that I started with, and then minus 3. That is my nth term. That expression will allow me to find anything. Okay, I notice I'm running out of time here. Hold on one second. Okay, I filled in the answers for the 91st term and the 500th term. All I had to do was to remember to subtract 3. All right, that's your lesson for today. Mr. Lawrence signing off. Good night, everybody.